light coming from something moving away gets distorted or redshifted. Sound does something similar. Here's an example. Watch as this car drives by as the driver annoyingly honks the horn. Listen to how the sound changes as the car races away. In the same way as sound waves from the car shift to make a different sound as the car moves away, the light waves from galaxies flying away from us shift to appear as a different color. We call this redshifting. Hubble understood that the redshifting of the galaxies happens because they are moving apart from an initial explosion. This means that space itself is being stretched bigger and bigger and is carrying the galaxies with it. And then came Robert Wilson and Arno Penzias. They were two radio astronomers who worked for Bell Laboratories. They were studying the microwave sky to potentially use it for microwave communication. This was in 1964, before cell phones.
So I worked very hard using a fair amount of the stockholders' money. In those days it was thousands of dollars, which is not a lot, on liquid helium to cool a noise standard so I could compare the galactic halo to some source of absolute temperature.
They built a very powerful antenna, but they kept hearing static, a background hiss that filled the entire background sky. They tried everything to get rid of the noise. After consulting with a team of Princeton physicists, Penzias and Wilson had a eureka moment.
You look at a star, the star's out there all day, and the reason you don't see them in the day is because light's in between. We know about stars because we measure the darkness next to them. But when you're inside the Milky Way, you can't turn away from it, and so we had to have something like that, and that's what I built, a standard of noise. And I expected that noise standard to be cold, a little bit warmer than the night sky.
The only way something could be in every part of the sky is if it was part of a cosmic event.